Hi everyone, welcome back to part 3 of the Leetcode Solver series. In the previous video, we explored how we could use the completions API to pass in the prompt containing a Leetcode question, and we were able to get back a completion that contains the Leetcode solution. We then explored how we could extract out just the completion or the Leetcode solution by getting it via a series of key accesses through the dictionary object that was passed back to us. So now for this third part, we'll be exploring how we can tie that together with a simple prototype application using the Streamlit library. So the Streamlit library is a Python library that allows us to come up with functional prototypes in as little lines of code as possible. So how it does that is that it gives us a couple of components that we can render with functions in the Streamlit library. For example, if you wish to render a header like this, rendering it is as simple as doing streamlit.header and passing in the text that you want the header to contain in the first parameter of the function. And on top of that, we will explore how there are so many components that we can use for this project. For example, if you wish to pass in a Leetcode question, there is a multi-line text input which we can use to render that widget, and we can extract the contents of that widget into a given string variable. We also have buttons that allows us to trigger actions if we click on it, and that is also a Streamlit text widget that allows us to show, for example, the solution of a Leetcode question given back to us by GPT3. So in this part, we'll be exploring how we can combine these widgets together to form a very simple Streamlit application that takes in a question and gives back the answer for that Leetcode question. So pardon my very terrible wireframing skills here, but this is a very simple schematic of how our application will look like. So in summary, it's just 5 widgets on a simple Streamlit application. The first widget is just a questions header that just hints to the user to pass us a Leetcode question. The second widget is a multi-line input widget, which will take in the Leetcode question. We will also have a submit button as a third component. If the user clicks it, then we will show the fourth and the fifth widget, which is just the answer header, as well as the multi-line text that contains the completion, or in this case, the Leetcode solution for that given question. So that's pretty much it. And now, for the third part of this video, we'll be continuing off from where we start, and we'll be going into building this Streamlit application. So with that, let's get started. In the previous video, we used this main.py file to experiment with GPT-3, and we show how we could set the API key, how we could create a completion object to call the class method on it to pass in a prompt, and how we did that using the class method create to create a completion. So calling create with a prompt is analogous to just making an API call to OpenAI and get back a response. We also explored like 3 very simple parameters to create, which is the model that you want to use, the prompt or the instructions to be passed to the model, and also the maximum amount of tokens that the completion is expected to give back to us. So this response object, we also explored, this is really an object of type OpenAI object, which is just a child class inheriting from the dictionary class over here. And we explored how we could get the given completion that we are looking for by just key value accesses like this. So that's pretty much it as a recap from the previous video. Now, before we start using main.py as the entry point of our Streamlit application, let's move all of this logic into a separate script, and let's call that OpenAI utils. We will then refactor this into a simple method that takes in a Leetcode question and gives you back a Leetcode answer. So I will first do that by creating a file and just call this OpenAI utils.py. So to make our life a little easier, I'll be splitting right, and I'll be copying the contents of this file here and remove it here. This main file will contain the contents of the Streamlit application, so I'm just going to shift everything to OpenAI utils over here. So we'll be making this main file import OpenAI utils, and to be specific, we'll be using a function that we will define OpenAI utils that takes in a Leetcode question and gives back a Leetcode answer. But the lucky thing about importing is that when you import the file, it will run the whole file from top to bottom. And we show how we could set the API key on line 10 like this. So what this means is if we import this and this file gets executed, we can just set the API key upon importing by just putting this line at the top in OpenAI utils. So let's just leave it there. And we'll also leave the completion object on line 11 as well. This completion object will be reused every time the function is called. So now we can start defining the function and call this get Leetcode solution. Let's make this take in a Leetcode question of type string, and this function will return back a string like this. On line 16, we define the Leetcode question, but let's just remove that because that will be the parameter to this function. So let's indent all logic over here and make it part of the Leetcode solution. Now this prompt is really just adding additional instructions on top of the Leetcode question that's given to us so that the task is as clear to GPT-3 as possible. And what we do over here is we get back the response from OpenAI. And notice that in this case, we use 3 lines to get the completion from the OpenAI object. But now that we know how it behaves in the second video, we can really just combine this logic into a single line and just do this. So that's pretty much it. And instead of a list of a dictionary, we can just rename this to Leetcode solution. And we will return this Leetcode solution as the output of this function. And that's pretty much it. This is pretty much all we have to do for refactoring this OpenAI file. And now that we're done, let's cancel this and let's start with our Streamlit application in main.py. Before we start using Streamlit, we have to first install Streamlit. And to do that, let's quickly place the library that we want to install in our requirements.txt file. And we can pass in the requirements.txt file and into our Python installer package installer Python pip to install it. So what we see over here is that we installed Streamlit, and the version that it gave us back is the latest version as of 26th of July, which is 1.11.0. So let's specify the exact version inside requirements as usual. So the next time if another software engineer comes along and use this project, they know exactly which version they should use to play with this project. So now that we are done, we can start using this Streamlit library that we just installed. So let's import Streamlit as st, and now we can start playing with the widgets that we like to use. So just to recap, our wireframe looks like this. Let's first try rendering the questions widget over here. So to do that, the questions widget is really a header. And what we are doing now is we are looking at the API reference to better understand how it behaves. And what we see over here is that the header function over here that renders a header widget takes in 2 parameters. You can ignore the anchor. The highlight is the body. And the body says the text to display. So in this case, because we want to display the text Streamlit question, so let's do st.header followed by Streamlit question. Sorry, not Streamlit question, Leetcode question. Sorry, I need my coffee. But now we have just rendered the first component. The next part is to render the multi-line text widget over here to take in a Leetcode question from our user. So to do that, we have another widget for that, which is st.textArea. st.textArea takes in a couple of parameters, but the parameters that we need to pay attention to is label, a little hint to the user for what to place it in, to what to place inside. The value is what is being passed into the text area, and that will be populated by the user. And by default, it is set to an empty string. So the value will take on any value that is input to us by the user. And in this case, there's also a height that will control how high or how how, I guess, the height of, like its name suggests, the height of this text area. Let's set this to 600, and if you're wondering why 600, well, I took the chance to test this out before I start recording this video, and 600 works quite well. So let's just stick to 600. You can play with this at your own time, and you can decide what height you like to set this widget to. So now, let's do st.text area. And in this case, the first parameter is the hint. So the label that we're going to put that we want to show the user. So let's give them a hint. Copy and paste your Leetcode question here. And over here, once we're done, we can set the output of this text area to a Leetcode question variable like this. So this Leetcode question string variable will take on the value of this text area over here. And at this point, we have rendered the second component of this Streamlit application. The next thing is to render a submit button. And on clicking the submit button, we want the submit button to pass in the input that's given to us to GPT-3 and get back the output. So let's check out the API, and we can see that we have streamlit.button. So in this case, as usual, there are a lot of parameters. But for this tutorial, I'll be keeping it simple and use only the label over here. So the label indicates what text this button will show. So let's give it a simple Streamlit button label, which says get Leetcode solution. So this text will be displayed on the button when we render it. Let's do if Streamlit button. If this button is clicked, then this conditional will be set to true, and everything that is executed here in this if statement will run. So upon clicking this button, we want to pass the Leetcode question string to OpenAI. So let's do Leetcode answer string to be equals to OpenAI utils get Leetcode solution, and we will pass in the Leetcode question over here. So we are using the function that we defined just now to pass in the Leetcode question to OpenAI and get back the output. So now that we get the Leetcode answer, we can start rendering that in this multi-line text over here. Let's quickly come up with the header, as usual, Leetcode answer, and we can do st.text. st.text in this case is the final widget that we will use, and this is to display some text. And in this case, the text that we want to display is just the Leetcode answer that we get back from GPT-3. So let's pass in Leetcode answer, and this is pretty much our application. We have 11 lines. Actually, if you remove the white spaces, it's just 10 lines, right? Yes, we just created a full, like a pretty decent prototype with just 10 lines of Python code. I find that cool, man. But to run this Streamlit application, just do Streamlit run, followed by the path to the entry point of the Streamlit application, which is main.py. So now, what we just did is spin up the application on our localhost 8501 port. And now we can see that this text is pretty lean. Let's try setting the text area to have a height of 600 as we specified. I was getting a little sun now. I forgot about that step. But let's rerun this, and you can see that the text area is now much bigger. Let's go to problems and choose one of the easiest questions. You can try out with a harder question, but you get the idea. Let's copy this and paste it here, and you can choose to press Command Enter to register the input, or you can click the outside of this text widget to register this input. So now that we copied this question to this widget, the question is now registered under Leetcode question. Now let's try clicking Get Leetcode Solution, and now it should start running the logic of passing the question to GPT-3, getting back the completion, and getting only the text that represents the completion to be displayed in this Streamlit application. So let's just wait a little, taking some time to run. I guess we can explore optimizing this in the next question. But you get the idea. We were able to render the LeetCode answer, and in this case, this was the solution. I guess this is not ideal in this case. In fact, it gave us an ON square solution. Let's try running this again and let's see if it gives us a better LeetCode answer. Okay, now it gives us a pre-flight checklist. That is embarrassing. But as you can see, the GPT-3 model is not foolproof. It can give us back gibberish sometimes. And I guess the next part of this series can explore how we can fine-tune the model or how we can adjust the prompt so that the question is clearer to the model. So, but you get the idea. Let's try running this again. Okay, now this time, it gave us a solution. So, let's do sums, challenge this. Sorry, left, right. Okay, in this case, it sorted numbers and it gave the okay, looks great. Actually this should be the solution. Let's copy and paste it here. Let's call this toSum, and let's try running this code and see if this works. So let's run this. toSums take 2 positional arguments, but 3 were given. Of course, it was missing out the self keyword here. Let's run this again. Okay, in fact, it printed out the sum and it printed out numbers. Okay, let's try running this. Let's see if this solution that's given back from OpenAI. Okay, it didn't work this time. But this, I guess this is a candid video of how even GPT-3 can struggle with understanding a task, and how it's not really sufficient if we throw the solution, if we just throw a question or a task to OpenAI and expect it to perform well. But there are ways to optimize this model to perform well on general tasks. So I guess this is a good idea for a subsequent video for this series. But let's try running this again and hopefully it can find a solution to this simple question, palindrome number. Okay, now it generated this. Interesting. This time it just generates gibberish. Let's try it again. Okay. So let's see. Okay, it's taking some time. Let's see how this performs. Okay, this time it generates a solution. To be frank, it's not really fantastic. But let's see if this solution works this time. Okay. Invalid syntax. Wow. Okay. It didn't generate. Okay, it actually gave invalid Python solution here. Well, unfortunately, we were unable to have a good demonstration of how. Okay, this time it actually generated something. Let's try this time. Okay, self.x. Okay, let's try running this. Let's see. Okay, it actually works this time. Okay, so this time we were lucky, but you could see that this simple prototype is not foolproof. There were a couple of instances where it generated gibberish and the solution to the Leetcode question is not satisfactory. I guess this is a good precursor to explain why many machine learning engineers who work with GPT-3 struggle with prompt design, and how they also have to worry about other techniques to make GPT-3 perform better on other tasks, such as fine-tuning a model using a series of data. But I guess for this demonstration, it was a pretty good and decent introduction to using GPT-3 to solve Leetcode questions. So to wrap this up, I will just show you how we commit changes. Let's quickly add Streamlit as a dependency. Let's also just add in the Streamlit stuff. So feed Streamlit, add Streamlit widgets to main. And yes, I guess that's pretty much it. Let's just push this to master as well. And that's pretty much it for this demonstration. We've shown how we could easily come up with a simple prototype in just 12 lines of code and hook that up to Leetcode in just a matter of minutes. So I hope that you learned a lot from this session. I hope that this gives you some confidence to replicate this on your own. I would highly recommend you to try making this project your own and extend it with further features. And with that, that's pretty much the end of this part 3. We might have another session on prompt design as well as fine-tuning, but in the next series we'll talk more about that. So with that, I wish you good luck and we'll see you in maybe part 4. Have a good day.